Page 3 of the packet of slope field problems that you have includes numbers 19 and 20 that we're going to work out together. These are examples of problems in which you are given a differential equation and asked to sketch a solution curve through a given point. In number 19, we have the differential equation dy dx equals x times y, and you can see the slope field drawn for you and a solution curve already drawn through the point 0, 1. The first thing you're asked to do is to sketch a solution curve through the point 0, 2. You'll want to start by plotting the point itself, 0, 2. And then as you move to the left and to the right, you're going to follow the path of the slope cuts. So as you go to the right, you'll notice you have this positively sloped slope cut right there. So it looks like it should be going up like that, and pretty much similar to the left side. Another solution curve that would pass instead through the point 0, -1, plot the point first. If I were to go left first, notice in the third quadrant all of my slope cuts are positively sloped. So that means as I sketch this, it's going to look like that. Now what should be true if you sketch these correctly is if you are correctly following the path of the slope cut, if you were to pick any point on the curve you drew, draw yourself a little tangent line, it should be parallel to the slope cuts that are there in the vicinity of it. Going to the right in the fourth quadrant, all of my slopes are now negative. So I know they're going to go down like this. The interesting thing about slope fields is that you can really have infinitely many solution curves through them, and the particular one you want depends upon the initial condition that you are provided with. This is very much going back to those particular solutions you dealt with in the last unit with antiderivatives. In number 20, this is a slope field we had generated ourselves in one of our practice examples, the differential equation x plus y. The first one we're asked to sketch in terms of a solution curve is to pass through the point 0, 1. So that would be right here. Again, you want to follow the path of the slope cuts. So going to the right from that point, it definitely looks like you have to go upward like that. But as you go to the left, and we made mention of this in our earlier problem, notice right here all these diagonals. This is what we refer to as a slant asymptote. So as you draw your solution curve, you are going to be asymptotic to that slant asymptote. The other thing you might notice how you have here a series of horizontal slope cuts. That's telling us we're going to have a minimum someplace because of how the right side of this already looks. So probably what's going to happen is here's your minimum right there, and then you're going to follow along that slant asymptote. You're now asked to do a solution curve through the point -3, 0, which would be right here on the far left. This looks totally different from the solution curve you just sketched through the other point. If you take a look at all the slope cuts around this point, they all are negative slopes. And really all you're going to have is something like that. Notice how you're still asymptotic to this slant asymptote right there. But it looks very, very different from the other one that you drew. You'll be having many opportunities in the future to draw your own solution curves. This is just an example of 2 of them.